What is Moore's circle? Well, that's a hard question to answer, but here are some things to know about Moore's circle. First of all, it's useful for figuring out the shear stress and normal stress at any plane within an object. So let's pretend we're looking down a beam here, and it's kind of getting squeezed from the sides. So if we look at this plane that cuts all down through the beam, this two-dimensional plane, we can kind of see that it's being squeezed, so it's experiencing some normal stress, but no shear stress. So let's think of this plane as like plane X, and let's think of this plane as plane Y. Another thing to know about Moore's circle is that 2 points on it are X and Y, and they give both the normal stress and shear stress at points X and Y. And here's how Moore's circle does that. There's an axis system, but instead of X and Y, we have normal stress and shear stress. So 1 point here gives information about normal and shear stress. So point X, for instance, would go on the sigma axis. It would actually be negative, it would be over here, because this is compressive normal stress. And it'll go on that axis because there is no shear stress on this X plane. So that is point X. Here's generally how to go about finding point X. You just look to the right of the little diagram here. So we see there's compressive normal stress, so we know it's going to be negative, and oftentimes there'll be a little shear stress line. And in a case like this would be trying to shear it clockwise, so that would be a positive shear stress, so it would go somewhere on the positive Y or shear stress axis. But in this situation, there's no shear given there, so we got point X. For point Y, we look above the beam, and here there's no normal stress, there's no shear stress, so point Y in this situation just goes at the origin. Another thing to know about Moore's circle is that points X and Y are at opposite sides of the circle. So we could just draw a circle where X and Y are on opposite sides, and there you go, we have Moore's circle for this situation. Here's another thing to know about Moore's circle. It will give you the stresses in all planes of a beam. So here's the X plane. If we were to rotate a little bit our plane, we would rotate on the circle. We can keep rotating planes until we come all the way back. 100 degrees later, we come back to our original plane. So that's 180 degrees of rotation. You can go through every plane in that beam. But Moore's circle is a circle. It's 360 degrees. So when we rotate theta degrees the plane of our beam, we have to rotate 2 theta on Moore's circle to find the point that's going to represent that plane that we are looking at in our beam. Right. For example, let's look at this plane that goes corner through corner. If we want to figure out the stresses in this plane, we have to rotate around Moore's circle a full 90 degrees, because that's double where we rotated the plane. So we rotated our plane here 45 degrees, which means we'd have to rotate 90 degrees in Moore's circle. And we come to this point on the circle. So that's telling us that we have a little less normal stress because we went toward the origin on the normal stress axis, And it's telling us that we now have shear stress because we went way up there on the shear stress axis. Okay, you may not believe me about that, because if you look at this diagram, it only says that there's normal stress. We're just smushing it from the right and left. But think about what would happen if we actually cut with a knife and we had two separate blocks. And we have two separate blocks and we smush them together. Do you see how they're going to kind of slide across each other like this and kind of shear? So like Moore's circle tells us, there is actually some shear stress in this plane here. And here's our point that represents this plane. That's saying that there's positive shear stress, which means it should be shearing clockwise, and it looks like that's what it's trying to do. So there you have it.